Hello guys, so welcome back to our discussion about diode clipping, and we're still discussing the dual clipping circuits, the circuits that clip from both a positive side and negative side of any signal, input signal. Okay, and last time we explore, a version of that circuit in which you have two batteries, you have two branches. It's pretty much assembly or integration of the previous two circuits that we discussed that they do separately the negative and positive clipping. Okay, here is another intelligent approach basically to implement it using just one power supply, one battery. Okay, and a potentiometer. So this is the first time to see a potentiometer in our course. So this guy here is a potentiometer, which is just a variable resistor. Okay, so let's see what is the requirement for what the two batteries that we put in the two branches of the diodes last time make in or cause to our circuit. Okay, so if we go back here to the circuit that we discussed, these two batteries, okay, provide fixed voltages at that point and that point. And that point, the voltage would be all the time constant, equal to VB1, and at that point the voltage all the time will be equal to minus VB2. So if you have such characteristic in your circuit, in your two branches, that the negative terminal, the N terminal of VD1 has a constant voltage, whatever it is, based on your desired clipping level, and the B terminal of VD2 again has a constant voltage, again based on the level would be based on your desired clipping voltage, then you will have clipping in both sides. So this circuit here with one power supply and a potentiometer can achieve that for you. Okay, so there are two secrets here. There are one secret basically, and the secret is to achieve this is to connect the arrow of the potentiometer, the controller, to the ground. That's the secret. Okay, so this will divide the resistance of the potentiometer into two parts. Okay, this part here, let's call it part 2, and this part here, which is part number 1. Okay, and remember now, you can imagine this potentiometer just like this. Two resistors with ground in between. Okay, and here is VB1, the voltage of that terminal, and here is VB2, the voltage of that terminal. Okay, and this is part 1, this is part 2. Okay, that's basically what the model of that potentiometer right now. Okay, that's very good. Now just look at this, this loop here. So basically, or even that branch. So E is basically VB1 minus VB2. Okay, VB1 minus VB2. So since if, for example, if let's have now a first case, if the arrow or the controller of the potentiometer is 50%, I mean it's at the middle here, at exactly the middle. Okay, then VB1 as a magnitude will be equal to VB2 as a magnitude, because basically, this is if this is RB1, this is RB2, because RB1 is equal to RB2. Okay, as a magnitude, again, as a magnitude. Okay, so in that case, what's gonna happen is that since this is a 0, okay, so VB1 must be positive, and VB2 must be negative. Like, for example, -1, -2, something like this. So in that particular case, okay, let's assume that E is equal to 8 volt. So VB1 will be 4 volt and VB2 will be minus 4 volt. Constant forever. Okay, as long as, of course, the arrow of the potentiometer or the controller of the potentiometer is at 50% of this potentiometer. Okay, so that's basically how you create. So with the 50% here, we have here 4 volt. We have here minus 4 volt. Let's now check what we got when we have two batteries. In that case, if V1 is 4, this guy is 4. If this guy is 4, VB2, this guy is minus 4. So that's exactly what we have in our circuit, although we just used one source, one battery, one power supply. Okay. And then the rest of the analysis will be exactly the same. Just copy and paste from our previous example. Just copy and paste. Okay. And of course, since the analysis is the same, then the outputs, I mean, VR and VR and VO will be exactly the same. I mean, you will have a clipping at VB. This is VB. Or VB1 in that case. Plus 0.7. And here is minus VB1 or minus VB2, I'm sorry, or plus VB2 minus 0.7 because VB2 is negative. So so negative is negative 4 minus 0.7 will give you minus 4.7. So for VR, this one here will be Vmax minus VB1 plus 0.7, which is 10 minus 4.7 will be 5.3. And this value here is minus Vmax minus VB2 minus 0.7. So it will be 10 minus 10 plus 4 plus 0.7. It will be at the end minus 5.3 volt. Okay. Good. Now let's use the potentiometer. That's another important characteristic. It's really easy here to control the voltage levels or the clipping levels. Just move the potentiometer. Okay, so let's do two examples. Let's move, for example, move the potentiometer to the far right, then the far left. So let's move the potentiometer to here. This is number 1 here. So basically, in that case, number 1, so in position 1, which is far right, RB2 is 0, and RB1 is just equal to RB, the total value, whatever RB is. By the way, we don't care about RB here, okay, except in one thing, and I will explain it at the end of this lecture. Okay, so in that case, so you can imagine so this is RB2 equal to 0, and here is RB1 equal to RB. Okay, so in that case, VB2 would be 0 because basically this arrow is connected to the ground, so we connect VB2 to 0. So VB1 will be equal to E. In that case here, E equal to A. Now let's draw this. Let's draw this with another color, like for example, green, something different. So we will have a clipping. Just apply here. VB1 is 8 now, so we'll have a clipping at 8.7. So if remember this is the maximum, here is 10. Okay. So we will have a clipping at 8.7, so something close to 10, something like here. Or let's do it, here and go back and go down. So this is, for example, 8.7. So if we go down like this, okay. So here is, the limits. Now let's draw the new level. So it's basically we're gonna continue. We'll not stop here at 4.7 like before. No, we're gonna continue until we reach the 8.7. So this is, for example, the 8.7. It's really narrow, but anyways. And again here. So the clipping is a little bit higher. Okay. How about VR? So VR will again be a triangle like this one here. So basically this triangle is a small one, is exactly this one. And the top of that triangle also changed. It will be Vmax minus 10.7. It will be 1.3 volt. Very small now. Okay. And let's do now the second level, which is so VB2 is 0. So if VB2 is 0, again, just apply here. Remember, this value here is minus VB2 or plus VB2 minus 0.7. So if VB2 is 0, this will be minus 0.7, just minus 0.7. So this will go up now. So assume, for example, this is 0.7. Let's make it a line like this. And go down. And another line here. So the clipping at the D side, at VO, will be just here like this. And this is minus 0.7. So the new shape we can say is like this. This is the new shape of the output, of the output. Higher level of clipping at the positive, and the lower level of clipping at the negative. How about VR? So we're gonna have a bigger VR now. So something like this. So this value here, remember, in the beginning we have minus 5.3 or minus 10, minus 4, minus 0.7. This will be minus Vmax, minus VB2 again, minus 0.7. So plus 0.7, this is basically 9.3. Minus 9.3. Okay, and again, this new shape here is exactly this one. Okay, and this cutting here is exactly that one. Again, this is Kirchhoff. Okay, let's have another example. Let's do another clipping, or let's go with this one, sine, for example. Let's now put the potentiometer at that location. This is number 2 here. So in that location, VB1 is connected to ground. So position far left. So RB1 now is 0, and the RB2 now is equal to RB. So it's just like this. This is RB2 equal to RB, and this is just RB1 equal to 0. So VB1 is equal to 0, and VB2 equal to minus E. Just, substitute in that relation. So this guy is 0, so multiply both sides with minus, so VB2 will be minus E or minus 8. Minus 8 volt. Okay, so we'll have just the opposite stuff here. So Let's check now where is the positive clipping. So the positive clipping will happen at 0 plus 0.7, which is 0.7. So something like this one. This is 0.7. So let's go down from that guy here. I'm sorry. This is a 0.7. So I'm gonna go down like this. So this is the new clipping. It will be this way. This cyan here. I know it's really ugly, but you know. And for VR, if you go down, we're gonna have a bigger VR now. Opposite to the first case. It would be something like this. And this value is Vmax minus 0.7 equal to 9.3. How about the other case? So in the negative clipping, VB2 now is minus E. So the clipping will happen at minus 8.7. So it's really big. So maybe here, for example. This is just a sketch, so you can assume whatever you want. And let's go down. It's really bad, but anyways. And here is the other one. Let's now draw that. So now the clipping and the negative will happen at VB2, which is 8 minus 0.7, it will be minus 8.7. So it's gonna continue and I'm gonna clip here. And that level here is minus 8.7. And for the resistor, we're gonna have a small triangle, okay? And this will be minus 1.3, which is minus Vmax, which is minus 10 plus 8.7. Okay, and again, that guy is exactly that guy. Okay, so that's basically a very flexible, we can say, and cheaper also, a circuit that do the dual clipping for you. Okay, it's just a potentiometer and one battery, and you, by controlling the potentiometer, you can get whatever clipping level you want in a very smart way. So one last thing about this circuit, very important observation, is that it has a condition to work properly, okay? And that condition is that R, this resistor here, must be larger than or much larger than RB. For example, 1 kilo ohm and 1 ohm, something like this. Okay, to see that beautiful drawings, and beautiful control and stuff for clipping, R must be larger than RB. I can't explain it here in that context why the reason, but I'm gonna make it as a separate problem. So we're gonna have a diode and 2 series resistors, okay, and we're gonna see that the effect of the resistor will affect the clipping level. Okay, so I'm gonna in the next video I'm gonna go over that new circuit that will explain to us why RB must be much less than R. Okay, so thank you very much for watching this video and see you in the next video. Bye bye.